Okay, let's do problem 3 on page 140 in chapter 5. And I modified the problem a little bit here, but it says a 3 kilogram object undergoes an acceleration given by A equals 2 in the I hat plus 5 in the J hat meters per second squared. Find the magnitude and direction of the resultant force. So I'm going to use given. The mass is 3.00 kilograms. The acceleration is 2.00 I hat plus 5.00 J hat meters per second squared. And what are you trying to find? You want to find the resultant force. Or actually, I should call this the net force. I should have called it the net force there. So, let's solve it. The net force equals MA. So this is going to be M times A. M is 3.00 kilograms. A is just given to be this. Now this is a vector quantity, and this is a scalar quantity. Mass is a scalar, but vector mathematics just lets me multiply a vector times a scalar. It doesn't change the direction at all. It just changes the magnitudes in front of each unit vector. And so the net force is going to be equal to 3 times 2 is 6, and plus 15 in the J hat. And then looking at the units, it's a kilogram meter per second squared. That's defined to be a Newton. Oh, one of the things, though, it says it wants a magnitude and direction. So, I mean, if I didn't say that, if I just said find the net force, or find the resultant force, then you could stop there. But the magnitude of the net force is just equal to the square root of 6 newtons squared plus 15 newtons squared. And I believe if you round it off to 3 significant figures, plug that in your calculator and you get 16.2 newtons. And then to find the angle, use inverse tangent of the y value over the x value. And they're both positive. That's nice. So theta equals, what was it? 68 point, was it 68.2? What'd you guys get? Degrees. Somebody had their calculator in radians when because it was, somebody put like 1 point something degrees. And it's like, look at the number and the units, you can kind of see that. Notice I didn't really draw any kind of a sketch for this, which is bad. I could probably draw the acceleration as over 2 up 5. So there's my acceleration vector. And then all the mass does is change the length of this and change the units of it from meters per second squared to newtons. And so I can say, okay, the resulting force, or the net force, had to be 16.2 newtons at an angle of 68.2 degrees. I think in the book, they actually didn't really require you to figure out the angle. They just wanted but I thought, nah, I'm going to make you find the angle as well. Magnitude and direction, because that's a very common thing for them to do. Now, one of the things, just to quickly mention, a lot of people, and I don't feel bad about this at all. I mean, good for you. A lot of people were trying to apply the procedure to this problem. Drawing a free body diagram and doing all that. But remember, this this particular problem was very early. It's before the procedure. And you see, you use the procedure. What you really want the procedure to do is to find out what that net force is. Or sometimes the net force is 0. But in this problem, you're given the acceleration, you're given the mass. If they give you the mass and the acceleration, you can find the net force right away. Just multiply them together. That's it. You don't need to do anything else. So, anyway, any questions on this problem? Okay, that is all.